My name is Kashyap Mavani, and in this video, I'll be explaining my solutions for assignment 1, Comp3132, user fashion mass dataset. I'll go step by step through the code and answer the given questions. So let's get started. Question 1, which is what are the dimensions of train images and labels and testing images and labels? So we use our first the fashion men's dataset we need to use. We'll import it from the Keras and Princess shapes, and as you can see we download it here from the dataset of training and testing both, and then we down there prints the shape of it so we know what the size and length are. The training set has around 60,000 images of size 28 by 28, and the test set has about 10,000 images of the same size. So the labels are stored as separate arrays. You can see both the labels and shapes have been shown right here. Let's go down to question 3, which is showing training and test labels. So next I printed the first 10 labels from the train and test dataset, and these numbers represents clothing categories ranging from 0 to 9 with labels such as t-shirts, dresses, sneakers, etc. As for question 5 to almost 7, what we are doing is we are displaying images. So let's display the image fifth from the training set, right? And there we go. So as numbers, it will show you the image right here. And for the digital content and plotting image at index 500 in the testing dataset, we'll do the same thing. Just remember to change right here. It's a bit mixed out, but yes, I also displayed the 500 image the same way as we displayed the fifth image. And the image actually belongs to the category. If you look up actual label, going down, we would see the label for the index fifth in the training level. And from the fashion classes, I actually looked up the actual label names using this list. And the label numbers match the clothing categories from the fashion men's data set, showing the accuracy of it. As for question 9, it does the same thing, just for the image 500. So we use the same method as per testing and training. It's just different labels, that's all. As for question 10 and 11, we are building essentially a neural network. So let me start by explaining the model architecture and the layers. I built a sequential model using Keras, and we import them, just the Keras code, and then for defining we use this. We flatten it out so we can just change it, and we use the softmax and relu for activation. I've used flatten to convert 28 by 28 images into a single vector of 784 pixel. As for the hidden two layers, we have 512 and 128 neurons, both using the relu activation. As for the final layers, has 10 neurons with softmax activation to predict clothing categories. Since it's lower, we can use softmax. It works just fine. Why are we using softmax? Softmax converts raw output into probabilities. It also ensures while doing that the total probability sums to 1, helping determine the most probable class, which is why for categories such as clothing, it works just fine and we use softmax as per the preference. For question 13 and 14, we are essentially doing a model compilation as well as training. So I'll show you a model compilation and the training of 10 epochs in a minute. But let me start by saying what I did. What I did first was I compiled and trained the model using two different optimizer. The first optimizer I've used is Adam, and the second one is RMS prop optimizer. I compare both optimizers to see how they actually affect the training performance. And then on the question 15th, we trained 10 epochs. There you can see all trends have been trained with accuracies and loss, and everything looks good. Going down to question 16 and 18, accuracy and overfitting essentially is both the same thing. It's just fashion Minsk is harder than the Minsk because clothing items have more variations in texture and shape. Regular Minsk achieves 98 to 99% accuracy, but fashion Minsk is lower, so somewhere around 90 to 92%. Some clothing items like t-shirts versus pullovers are a bit more harder to classify. As for overfitting, I checked for overfitting by evaluating test accuracies right here on question 18. There we go. And to show it in a more better way, we have plotted graphs for the training loss versus the validation loss, and it looks pretty neat. And as for the final model accuracy, we write a very basic code to evaluate the model accuracy, and the accuracy is around 0.85 with the loss of 0.4 test, which is pretty okay, but considering it's a fashion mask, the lower accuracy makes more sense. If it was regular, we would have more, but since it's fashion with more categories, it's harder for a model to be more accurate. As for question 20 and 21, how do we overfit and how do we check? It's well, we just use test accuracy and test loss and with cross references. And if the test accuracy is much lower than the training accuracy, it means the model is overfitting. Therefore, it memorizes training data but doesn't generalize well. So in conclusion, if the training data is very high but the test accuracy is low, the model is overfitting and thus needs improvements to generalize better. Otherwise, it's doing perfect. I have uploaded my Jupyter notebook and added the video link in D2L. And as per conclusion, overfitting can be reduced with the dropout and regularization. That's all for my assignment. Thank you.